Hello.
Okay, guys, so let's start. Most of us have joined in, and is everyone comfortable with Hindi, or is anyone having a problem with Hindi? If anyone has a problem, they can send in the chat, or else I would be starting in Hindi. Okay, so it looks like we have people who are comfortable with Hindi, sorry, English. So we
పిల్లలు
go with
ఇంట్లో ఉంటారా
English itself. We can definitely go with English as well. So I would request you all to just mute yourself. There's a lot of background noise.
నువ్వు అనిపిస్తావా ఏమి రావు కదా అయిపోతుంది
Okay, so my today's topic is basics of networking. Today I would be covering the very basics of the networking as to what networking is, the basics of it, like OSI model, the network topologies that we have, the networking devices, and the TCPIP model. What is it? Why do we use it? What is the difference between the OSI and the TCPIP models? Then we would be doing a little bit of IP addressing, the public IP addresses, the private IP addresses, IPv4, IPv6. Why do we need subnets? How do we create subnets? What is CIDR or VLSM, which is basically classless interdomain routing or variable length subnet masking, how we calculate those portions, what is static routing, what is dynamic routing, the protocols that are involved with it, and I would be even showing you a demo as well as to how you can configure them on your systems for practice. And then we would be touching a little bit on NATPAT and NAT over PAT. And the reason for including NATPAT and NAT over PAT on the very first stage itself is because this is like the most interesting feature in the networking which we are using on everyday basis, but we have no idea as to how it is working and why it was brought into, like, was it brought into the play. So, like, before we start with everything, let's start with getting the system set up. So I personally prefer GNS3. Now, GNS3 is like a much more advanced tool when it comes to practicing networking. Let me show you the of it. So this is like the basic interface of GNS3. Now you have various functionalities. You can add your own routers, switches, end devices. Everything can be added up manually with the help of the ISO images and the other operating systems that we have. Like Juniper has their own operating system known as Junos, whereas Cisco has iOS devices, not the Apple iOS, but the Cisco's proprietary iOS operating system. And various firewalls have their own operating system, like Fortinet has its own. There is pfSense, Checkpoint, various devices are there. So you can add all those ISOs up over here and you can like implement them in no time. So it is like you have to simply drag and drop and use it. But first of all, you would have to add those ISOs and then you would be able to use it. So for your benefit, for or the ones who are just starting to work with networking and just want to play around, I would suggest going for packet tracer.
Yes,
Yep. So what you have to do is to get packet tracer, you have to go to Net Academy, which is basically a place by the Cisco, and you can register and download it. So as I already have my a registered account, so let me just quickly log in. So once you log into the portal, on the resources option, you would have the download packet tracer option. You can simply go ahead and install it on your Windows machine, Linux machine, Mac OS. Even mobile devices are supported. If you have an Android device, you can go to Play Store and get packet tracer on your mobile as well. Even for iOS is there. I haven't tried the iOS version, but Android version, I would suggest don't go for it. Instead, go install it on your system itself. Okay, so while it is downloading, let's start with the basics. So, what basically is networks, or why did we need networks? So, the reason we created networks is because the computing stage was going through an immense development and we needed them to communicate with each other, to share the resources that are there, to share the data that we have. So that is the reason the network was created, or basically internet that we know as of today was created. It was created with the very first option, the model known as the OSI model. Okay, so the OSI model was the reference model that helped in the modern day networking. OSI model, or even known as the Open System Interconnection Model, is the reference model, or basically the full form of OSI model is Open System Model. Now, OSI model is basically of 7 layers: application layer, the presentation layer, the session layer, the transfer.
Excuse me.
Yep.
Can you please tell him to mute his mic? That Galaxy A7.
Just a second. This would be better. Yep. So the 7 layers are the application layer, the presentation layer, the session layer, the transport layer, the network layer, the data link layer, and the physical layer. Remembering them on serial format is quite tough for the people who are new into the networking field. So there are mnemonic terms for them. The personal favorite of mine, being a foodie, is all people seem to need Domino's pizza. That is the one that I personally like it, and that is how even I memorized all these 7 layers. But these 7 layers are not exactly in the same order. Application layer is not the first layer. The physical layer is the first layer. Application layer is the seventh layer. So it is like written in a backward format. Application, presentation, session, transport, network, data link, and physical. So these are 7, 6, 5, 4, 3, 2, 1. And this OSI model came into play in around early, or you can even say after mid 1970s. So the networks that we know of is hardly like 50 years old. And within that, as you can see, from basically nothing to the modern day internet, you can access resources from just like a blink of an eye. You are able to get any information from any part of the world, and that too at an amazingly fast speed. That is like the beauty of networking, and we network engineers try to maintain it in that particular format itself. So there is a saying which I don't know if you have heard it or not, but at least in the network community, it is quite prevalent and is known as we change routes faster than your eye blinks. So your internet routes are controlled and they are changed faster than the eye blink. So even before you blink your eye, your network route has been changed and you won't even know about it. Okay, so like that was the basic reference model which helped us in creating the modern day networks. On the basis of this OSI model, came across the current model, or the model that we use, known as the TCPIP model. And on the basis of this model is the modern day networks working on. Now, the basic difference between the OSI model and the TCP/IP model is that the TCP/IP model is of just 4 layers: application layer, transport layer, internet, and the data link layer or the link layer. So if you look closely, let me like bring up a whiteboard. Where is the whiteboard option? Yeah. So if say suppose I had application presentation session transport network data link and the physical. On the TCP/IP model, we just have the application, the transport, the internet, and the data link or the link layer. So these four layers are there. So the first three are combined into one, which is known as the application layer. The transport remains as it is. The network becomes the internet, and again, the last two layers, that is the data link and the physical layer, gets converted into one single one, and that is known as the data link or the link layer. So that is the major difference between the OSI and the TCP model. Now, the other differences that in are or more prevalent rather than just the layers is like TCP/IP model is an implementation of the OSI model, whereas the OSI model was just a reference model. So that is like the primary difference between them, because OSI model never came into existence. It was just always used as a reference model. It was never developed into a working format. Now, as I again told you previously, the modern day internet is based on the TCP/IP model. And again, as TCP/IP model is an actual implementation of the OSI model, so again, the OSI model becomes a theoretical concept. Now, there is a major difference between the TCP/IP model and the OSI model. That the major difference is that the protocols are not strictly defined. So, if you remember, there are 7 layers on the OSI model and 4 layers on the TCP/IP model. In networking, everything is controlled by the protocols. Even if you don't take networking, on other portions of the computers as well. So if say suppose there is an application running, application is even controlled by some source code or some code that follows a particular format. So that particular format in the networking is known as protocols. So in OSI model, each protocol was like what you can say made specific for a layer. So say suppose if I'm talking about the application layer, the HTTP protocol or say suppose FTP protocol, they would be just dealing with the application layer. They won't come on to the presentation layer or they won't come in the session layer. They are specific for the application layer and they remain specific to the application layer. Whereas in the TCP/IP model, it is not that case. So, as the layers are minimum, so the protocols are even like they even work hand in hand with each other. So, protocols are not directly or strictly defined in TCP/IP model, whereas it is strictly defined in the OSI model. Now, let me give you a brief idea as to what each layer contains, and how or what or which protocols they work on. So on the OSI model, the application layer works on any protocol that deals with the application. So say suppose if you take the SMTP protocol that is responsible for the email delivery, again connected to an application. That is the reason it is on the application layer. Now, say suppose if you take any encryption. Encryption is connected to the presentation layer. So once you have the what you want to send or which protocol you would be using to send the packet on, then you need to encrypt it because we all are from mostly the security industry. So we need to secure whatever we have. So that is when the encryption comes into play. And encryption is on the second layer of the OSI model, or basically it belongs to the presentation layer, which is in turn the second layer of the OSI model. The third soon comes the session layer. So as the name suggests, it deals only with how people would be communicating, how long they would be communicating. So it basically deals with the communication portion. Then we have the transport layer. So the transport layer basically is responsible for delivering those packets. So if you people know, there is a known as a TCP handshake, which is a three-way handshake. You send a SYN packet, you receive a SYN and ACK packet, and then you finally transmit an acknowledgement packet. So all those things are done on the transport layer. Then comes the network layer. So network layer is mostly responsible for the addressing like IPv4 address, IPv6 address, and then how the data would be routed, which traffic model they would be following, and how they would be getting transferred. That comes under the network layer. Then we have the data link layer. Now, data link layer deals with the frame technology. Now, frame technology is something quite complex. I won't get much in details into it. So, just for like a very brief example, MAC addresses um, are involved in the data link layer. So, if you don't have a MAC address, even if all the layers are working fine, you won't be able to deliver out a packet, and you won't be able to communicate to any of the systems in the world. So you always need a MAC address or the frames that define the data link layer. And then we finally have the physical layer, which is responsible for delivering the data to the network. Now, this can be any physical medium, wireless medium, anything. So your normal Ethernet cable falls under the physical layer. Your optic fiber connections are in the physical layer. Any kind of medium that is used to transmit the packets through the network comes under the physical layer. So, any questions up till now? I know these theory stuff are boring, but don't get bored. We would definitely come to the interesting portions of configuring the networks as well. So if you have any questions, then you can, or I would like move to the other portion. Okay, no questions, no problem. So, okay, Dhani's raised hand. Yes, Dhani, you can go ahead ask your question.
No, I don't have any doubt. I guess there was a message on Zoom, so I was just
Okay, no problem.
reading it. Yeah, so far I guess no doubts from anyone.
Okay, so like the major portion of the networking is completed, if to be very frank. Now, whatever we would be seeing is like the basic 40% of networking that is there. If you know this OSI model, TCP/IP model, 60% of networking is already completed. That's how easy networking is. Okay, so now we have the network topology, networking devices. Now, the way we connect systems defines as to what the network topology we are going to follow. So there can be various ways. We can start from point to point, daisy chain, bus topology, ring topology, mesh, hybrid, all those can be there. I cannot see the screen. So I guess I hope the screen should be visible now. If people were having a problem with. So now we have the network topologies. So we start from point to point, basically connecting two computers or two devices to each other. That is what a point to point is. Then we have daisy chains. So, like the normal definition of daisy chain is connecting devices serially. Now, in daisy chaining, it can be said as a bus or a normal, not, yeah, ring even can be included in a daisy chain as well. So these two of the topologies come under the daisy chain itself. Now, there are subdivisions of all these topologies as well, which I'm not going to get into so much of those details because those things are when you go for like a creation of the network itself. You have to design the network. So I'm not going to cover that on the basic sections. If you want, you can definitely go ahead. If you face any issues, you can contact me anytime, and I would be happy to help you regarding your doubts and queries. So I won't be going into much of the details right now. Um, so yes, as we were discussing, under daisy chain, bus topology and ring topology are included. Now, bus topology is a basic, simple topology when you connect all the devices to each other. That is basically a bus topology. Or let me show you a bus topology network diagram itself. So images. So this can be said as a bus topology when the systems are connected like directly to each other. Then in the ring topology, it is just the similar one. It is just in a ring format. So say suppose we have five systems. We start from system number one connected to system two gets connected to system three, and in so form, the system five connect back to system one again. That is what a ring topology is. Star topology, it is connected in a star format. Mesh topology is basically like you connect them anyhow. And then we have the final topology known as the hybrid topology. Hybrid topology is basically when you connect two or more topologies with each other. Say, suppose you have a star topology, along with that, you have a ring topology. When you mix them up, that becomes a hybrid topology. Now, in networking devices, we all have known or know about these devices, the network interface cards or the NIC that you have, where you basically connect your Ethernet jacks or your Wi-Fi adapters. Those are the network interface cards, which helps you in connecting to the networks. That is a networking device. Then we have routers, switches, repeaters, hubs, bridges, firewalls, load balancers, various other networking devices are there. So these are like some of the basics ones that we use on a daily basis, and you would be seeing them everywhere around you. Now comes the section about IP addressing. We all generally know that there are like two basic formats of IP addressing, IPv4 and IPv6. IPv4 addressing is an addressing format where we have 32 bits in an IP address. So, okay. So say suppose I have an IP address 192.168.10.10 slash 24. Don't worry about the slash 24. I would be explaining that later on. But this portion that I wrote, like basically 192.168.10.10, is of 32 bits. Now, if I had to convert them on binary format, it would be somewhat like, so in binary 192 would become this. So double one, double zero, double zero, double zero, and that's it. Then we have 168. So on decimal 168 would become 1010100 dot 10 would again become 00001010 dot 00001010. So this is the binary format of the IP address that we just wrote, 192.168.10.10. So as you can see, each portion of the IP address is of 8 bits and we have 4 sections. So that is the reason we have 32 bits in an IP address. Now let's come on to this slash 24. Now, in any IP address, be it the IPv4 address, IPv6 address, there is a minimum of always two portions. One is to represent the network, the other is to represent the host. So, the network and the host power portions are most prevalent in IPv4, but in IPv6, there are other portions as well, which includes like the interface ID, the subnet ID, all those portions are even included in the IP address itself. We would be coming that on that later on. So before that, let's explain the IPv4 portions. Now, as it is, or basically this 24 means that the 24 bits are for the network portion. The remaining 8 bits are for the host portion. So basically that means like mm, so 192.168.10 is basically my network ID, and the last 10 is basically my host ID. So if now anyone gives you an IP address in this format, I guess you would be able to tell them which portion is the network portion, which is the host portion, and how many hosts you can have in that network. Okay, so I haven't basically explained it. Let me explain that as well. So now as we know that the first 24 bits are for the network portion, that basically means that these last 8 bits are the only ones that we can play with. Okay, so let's convert it on binary as to what it would become. So one, one, one. So this is like the maximum number of bits that we can have, which is 8 ones, and it comes down to around 255. So the last IP address that we can have is of 255. So as my this last portion is representing the host ID, so the last IP address that I can have is of 255. So that basically means that this range 192.168.10.24 has almost 254 hosts. Any questions? Because this is kind of a tricky one. If it's not clear, do let me know.
Hello, can you please explain that part again? I didn't understand properly.
Which portion?
That 254 hosts.
Okay. So as we saw that the first three portions are already taken by the network. Okay. So we just are left with the last 8 bits, because the maximum one that we can have is 32 and we already have 24 taken. So 32 minus 24 equals to 8. Okay. These 8 bits are the ones that we can play with. And the maximum that we can go up to is all the 8 bits to be 1. Because if I try to increase more than that, it would go on another bit, which is basically the ninth bit. And we don't have the ninth bit with us. So that is the maximum we can go up to. And the maximum if is like all ones, then if we convert it into decimal format, it is 255. Okay.
Yeah.
So if anyone gives us this range and tells us how many IP addresses can you have, you can simply say them that there can be 254 IP addresses or 254 hosts. The reason we didn't go for 255 is because two IP addresses are always taken away. The first one, basically like the 192.168.10.0, this becomes the network representer, or basically the network IP. Okay, so the first that is basically 192.168.10.0 is used for representing the network and is known as the network IP. The last one that is left with us is 192.168.255. This is known as the broadcast IP. And we cannot even use this IP as well. Now, before explaining what broadcast IP is, let me explain you what broadcast, unicast, and multicast is. So, in networking, in IPv4, there are these four types of addresses: unicast address, broadcast address, and multicast address. Unicast address is basically when one system is communicating directly to other system. Okay, so on basically when we are when two systems are directly communicating with each other, that is when a unicast communication is happening. Whereas in broadcast, what happens is any data that is there would be transmitted to each and every system that is connected on the network. So say suppose you receive the data and you broadcast it in the network, then basically you are transferring the data to each and every system that is connected to your network. That is what broadcast is. And then we have the multicast. Multicast is kind of similar to broadcast, but not exactly like broadcast. Because in broadcast, what we did was we sent it out to each and every connected system. But in multicast, it won't be like just sending out to each and every system. It would be first of all sending out to, say, suppose a batch of 5 systems. If anyone is the recipient of that data, then it won't transmit it to any other systems. If then there is no recipient of the data within those 5 multicast requests, then those are transferred to another, say suppose 5 systems. That is how basically multicast works. And the reason that we have the broadcast IP is basically for the same to broadcast the data inside the network. Whatever data you receive, and if you are transmitting it on this IP address 192.168.10.255, then that basically means that you are sending it out to each and every system that is connected inside your network. So if you reduce it and then so 255 dot mm, or basically like 255 is removed, so we are left with 254, and the zero is even automatically taken away, so we are just left with 254 hosts. So that is the reason you would be having just 254 hosts inside your network. Is it clear now? So it's clear. Now I would be moving on to IPv6 address. IPv6 address is basically a 128-bit address and is not written in decimal format. It is written in hexadecimal format. So let me show up IP config. Nash all. So uh, if suppose I take this IP address itself, FE80 colon 1. So FE80 colon 1. So this basically is a loopback IPv6 address. This is not an actual IPv6 address which you can use out in the world, but this is a loopback address like we have in the IPv4 addressing scheme. So as you can see, it is in a hexadecimal FE80. So IPv6 is basically from 0 to 9 and A to F, because that is what the hexadecimal works on. Now, in any IPv6 address, there are three portions. The first 48 bits is for the global routing prefix. The next 16 bits is for the subnet ID, and the last 64 bits is the interface ID, or basically known as the MAC address. So these are the three portions of an IPv6 address. Now in IP addresses, there are classes as well. So there are 5 classes: A, B, C, D, and E, most prevalent in IPv4 addressing, as IPv6 addressing is of 128 bits and works on what do you say? It is on a hexadecimal format. It is not a very short range of IP addresses. It is quite a huge range, and plus adding of the interface ID makes each an IP makes each IP address unique, because no two interface IDs can be the same. So that is the reason we don't have the classes defined for IPv6 addresses. In IPv4, we have the A, B, C, D, and E. Now, the A is from 0 to 127. B is from 128 to 191. C is from 192 to 223. Sorry. D is from 224 to 239. And the last block is from 240 to 255. These are the 5 blocks of IPv4 addresses. Now, within these blocks, there are some ranges that have been kept for private use. they cannot be used out publicly in the networks. Because if we don't have the private IP addresses, we won't be able to like create an internal network. We would always have a public network. And that is the reason we created the internal IP ranges. So the internal IP ranges for class A is 10.0.0.0 slash 8. For class B, it is 172.16.0.0 slash 12. And for class C, it is 192.168.0.0 slash 16. These are the three private IP ranges that we can use. Now, each of these slashes even represent a subnet mask. But before coming on to the subnet mask, we first need to understand what a subnet is. So, as the IP ranges are quite huge, we have to divide them into smaller networks. And this is known as the subnet. And the process by which we do it is known as the subnetting process. So for this range, the subnet mask would be 255.0.0.0, or basically 255 would always be there because the first 8 bits are for the network. Subnet mask is always used for representing the network portions. So as 8 bits are for the network, so 255 is for the network. The other can be changed. So that is the reason they are completely zeros. So in that similar manner, 255 dot, what would be for flash 12? Can anybody say? You're free to use the calculator if you want to. So the first 4 bits would be 1 and the rest would be 0, which comes down to 240. So 255.240.0.0 is basically the subnet mask for private IP range of class B. And for class C, the subnet mask is 255.255.0.0. Any questions, any doubts?
चंद्रेश सर
Yep.
एक क्वेश्चन आया था अभी क्वेश्चन इज will you be taking classes on advanced networking as well?
Yes, I definitely can take classes on advanced networking as well. What kind of advanced networking is he exactly looking for? Is he
क्वेश्चन इतना ही
looking
था
for like complete CCNA course? क्या चाहिए उसको?
उस पर एडवांस चाहिए थोड़ा नॉट श्योर अब मैं फॉलो अप करता हूँ आप कंटिन्यू करो
Sure. Okay.
Like you will be dealing with certification courses for CCNA.
Sorry, I didn't get your question. Your voice broke.
CCNA certification course will be you will be helping with that.
Yes, I can even help you with certification courses. If you want to go for CCNA courses, I can definitely help you with that as well. If you want to go for Network Plus, which is also from CompTIA, I can help you on that as well. Even like CEH and all those certifications, I can definitely help you on that.
More advanced like MPLS and SD-WAN like that topics you will be telling.
Satish, your voice is totally breaking up. Can you type it? At least for us.
So I'm not sure who this Vivo1609 is, but his question is like 192.168.0.0/24. Is it a private IP address? Yes, it is a private IP address. SD-WAN and MPLS concepts. I'm sorry, buddy, I might not be able to help you on these sections, but I can definitely look up and refer you people who can help you on those portions if you want. Okay, so you can like drop in your email ID. If I find someone, I would definitely refer them to you. Okay, thanks, I'm Sagar. I'm not sure, Sagar, if I know you or not, but so if anyone has any doubts still how to create subnets or how to basically find the subnet mask, I guess there was no question, so I can proceed further. So the next portion that we have is the CIDR or VLSM, classless interdomain routing or the variable length subnet masking. This is a very important section again because, as we all know, IP addresses are IPv4 addresses have already been exhausted out, and we cannot simply give people the complete /24 series because that means that we would be giving them access to almost like 254 IP addresses. That is the reason we came up with a concept known as the CIDR or the classless interdomain routing. What basically happens in CIDR is basically like, say, suppose we have an IP address 230.0 slash, say, suppose 30. Okay, so if this is my range, this basically means that I'm creating a classless interdomain routing because the network portions remain the same, only the host portion changes. So if, say, suppose I had to create like expand it out, it would become 1203.163.230.0 would be my first IP address or basically my network ID. Now I just have 2 bits to play with. Okay, so if I play with just 2 bits, which is 11. So I can have a maximum of 3 IP addresses. So my last IP address would be 203.163.230.2. No, sorry, I would be having it on 3. Yes. So that basically gives me 2 IP addresses to be used. And my subnet mask would be 255.255.255 dot. Let's convert it into 111111 and double 0, which is 252. So this is basically what classless interdomain routing looks like when you create so smaller networks that you only provide the IP addresses that are exactly needed. Sorry, I'm got mixed it up. It is that portion is basically known as the variable length subnet masking, whereas the classless interdomain routing is when you create small networks so that the IP addresses are not being wasted. So now let's come to VLSM. Say suppose I need 5 IP addresses. Okay, so 5 IP addresses I need it to be used. And let's take this range itself. Instead of /30, we would be trying to find what our subnet mask and the slash would be. So if I need 5 IP addresses, the closest that we have is of 8, because 2 cube is 8. So whenever you like break portions of network, you always have to work on the 2 cube, 2 square, or 2 to the power 4, anything to the power 2. The nearest value that you can get is the one that you basically are looking for. So 2 cube is 8, and I don't need complete 8. I just need 5. So after that we have 2 square, or basically sorry, below that we have 2 square. 2 square plus 1. So that basically gives us 5 IP addresses. But I need 5 usable. So I would have to go with 2 cube itself. Okay, so now if anyone knows like the calculation or how to convert from binary to decimal, would even know that this is how we do it. So 2 to the power of, where is the power symbol? 2 to the power 7 plus 0 into 2 to the power of 6 plus 0 into 2 to the power 5 plus 0 into 2 to the power 4 plus 0 into 2 to the power, sorry, it would be 1. And 2 to the power 3 plus 1 into 2 to the power 2 plus 1 into 2 to the power of 1 plus 1 into 2 to the power of 0. which gives us 0 plus 0 plus 0 plus 0 plus 0. So 1, 2, 3, 4. 4 zeros. 1, 2, 3, 4 zeros. And we would be having 8 plus 4 plus 2 plus 1. 12, 14, and 115. So we don't need 15 IP addresses. So if we can see, this would again turn out to be 0. So this would again go back to 0, and 426 plus 1. 7. So basically the last 3 bits are being used. So 255.255.255 dot dot double one 1.23. So 240 is what we receive. So 248 becomes the subnet mask. This becomes our subnet mask, and we were using the last 3 bits. So 32 minus 3, which basically gives us 29. So again, 0 would be our starting IP address, and 7 would be the last IP address. So this is how you can create variable length subnet masks as well. Any questions up till now? I guess people have started sleeping. Is it, guys? Hmm? Are you guys sleepy? Because it feels like you guys are sleepy. Okay, so let's skip the explanation portions as of now, and we would be continuing on to that later on. Let me show you some practical demos. So let me start up my GNS3. Okay. So we would be creating a simple static routing so I'm taking a Cisco 2691 as my router. If you have any other preferences, you can definitely go through that as well. So here are my 2 routers, 2 switches, and yeah. Two systems for my router 1, and 2 systems for my router 2. Let's start connecting.
सर आपके स्क्रीन शेयर नहीं है, नहीं दिख रहा है किसी को भी।
सॉरी, प्लीज स्क्रीन शेयर करें किसी। चलिए कोई नहीं, अभी कर दे रहे हैं। अब देखिए सर।
हाँ अभी दिख रहा है।
हाँ, so as I told you earlier, I am using DNS3. You can use packet tracer as well. I would show you on packet tracer as well. Let me show you actually how we do configure these routers and switches. So once my systems or my basic configuration connections are done, I have to simply switch all of these on. And if you can see on my left hand side, if I want to access any one of them, I would have to do a telnet. So telnet localhost 5004 would give me access to PC1, which is basically my this system. So I'm going to use putty. So localhost. First, I'm going to configure my router 1, which is running on port 5000. Wait, increase the size. I hope the terminal is visible quite clearly. If you want, I can increase the font size as well. Now, whenever you start a router, you don't directly get into the Roman mode. As you can see, this basically means that we are into the Roman mode. Now, in any router or switch, when you would be going to configure it, you would first of all be getting something known as okay. It is like directly getting me into the Roman mode. So you would be getting a symbol known as basically the greater than symbol. So when you are on the greater than symbol, you have to go for enable. Then it would bring you onto this Roman mode where you can configure your routers and switches. But you would be able to do it from the mode itself. If you're not on this mode, you won't be able to do anything. So let's first give our so configure terminal is to get you onto the configuration mode where you would be able to configure everything. So first of all, I would be configuring my interface fast Ethernet 0 by 0. You can get a list of all the interfaces when it first starts or by even doing a show run. So interface fast Ethernet 0 by 0. By default, every port in a router is on the shutdown mode. Even if you power on the router, the ports won't start functioning until and unless you do a no shut. But before that, let me add an IP address to it. So 192.168 dot say something 1 and 255.255.255.0, or basically the subnet mask that I want to use. Once that is done, I can simply go ahead and do a no shut exit out of it. So as you can see, my interface fast Ethernet 0 by 0 changed state to up. And let's configure a DHCP server now. Okay, so service DHCP IP DHCP pool, and then you have to provide a pool name. So say suppose I'm going with test 1. Now you have to define your network. So my network is on 192.168.10.0, and then the subnet mask again. And once that is done, you have to provide in your default router as well. So my default router is going to be my particular router, which I have configured on 10.1. So exit out of it, again exit out. So basically now my router should be able to provide IP addresses to my systems as well. So if I do a connect on to a new session, telnet localhost, and the port is on 5004. So that is my PC1. Let me again increase the size. So IP address DHCP. Okay. So as you can see, I received an IP address 192.168.10.2/24. My gateway is 192.168.10.1. Now, if I ping my gateway, I should be getting a response. Yes, I am getting a response. Now, for the same way, let's configure our second device as well, or second PC, which is on a 5006 port. And I need it on telnet. Open. So DHCP-R to renew the DHCP. Now, as you can see, it is on 10.3. If I ping 192.168.10.2, I am receiving a reply. 10.1, I am receiving a reply. Let's check it from my second system for the second system as well. Yes, we are receiving replies. Now, this is only up to this portion has been completed. We have to configure the second routers and the systems as well. So let's connect on to our other router and new session, localhost 5001 telnet. So configure terminal. I'm going to use shortcuts now. I'm not going to type all in like the complete format. So conf t is the shortcut for configure terminal. Interface fast Ethernet 0 by 0. IP address 192.168.20.1 255.255.255.0 and no shut. Exit out and again service DHCP IP pool DHCP pool name. So let's give it a test 2. Oh, sorry, IP DHCP pool. Now network 192.168.20.0 255.255.255.0 default router 192.168.20.1. Okay, so my router's configuration for DHCP is set. Now let me configure the serial ports as well. Interface serial 0 by 0 by 0. Okay. Oops. So first of all, I have to give it an IP address. So let's give it something completely unique. So 10.2 and I would be going with a subnet mask of 255.255.0.0. No shut and exit out. So show controllers. Oops. I cannot go by that. Okay, clock rate is automatically set, so I'm not going to change any of those. Now on my router 1, I have to configure the same serial port again. So interface serial 0 by 0. IP address 172.16. Dot, what was the IP address? 10.1 255.55.0.0. 255 dot 55 dot 0 dot 0. 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 255 dot 55 dot 0 So now I have to do an IP route. So currently I would be just doing a static routing. So if you are like anytime confused as to what the next step is going to be, you can simply do a question mark and it would show you as to what your next option should be. So IP route static and so 192.168.20.0 255.255.255.0, it would be going through my serial port which is on 172.16.10.1. Nothing. One 172.116 dot sorry 10.2. So we have configured it on our first router. Let's configure on the second router as well. So IP route 192.168.10.0 255.255.255.0 and 172.16.10.1. Okay, now let's ping 192.168.10.2. So as you can see, we are having a success. So from the router, we are able to ping our other network, basically this network. Let's do it from our PC as well. First, I would have to like get the other two systems working as well. So local host and the port number would be 5008 and 5010. 5008 telnet. So DHCP hyphen renew. While it's renewing, let me change the appearance. So now we have an IP address 192.168.20.2. So now if I ping it from this system to my original network, I should be getting ping responses. So if I even ping my serial port interface, I would not be able to, because we didn't add any route to that interface. That is the reason I won't be able to ping any of my serial interface from any of my systems. So even if from this system, if I try to ping it, say even like my router, I would be able to. But if for the other router, oh no. So this is basically how you can configure your routers, and this was an example for static routing. Now the other portion that we have is like the dynamic routing. In dynamic routing, what happens is you would be letting the protocols decide as to how they would be transferring the packets and through which interface they would be allowing the protocols or the packets to flow through. Like as we currently did, we specified each and every port, that this port would be doing this, and only from the serial ports we allowed the network to pass through. So in dynamic routing, you can simply configure up a protocol, and on the basis of those protocols, it would be doing up all the tasks, finding the best possible route. The next hop it should connect to, all those would be done in the dynamic routing. So for example of dynamic routing, we have RIP, EIGRP, BGP. All those are some of the examples of dynamic routing. Now, the last portion which I was waiting for to discuss, the NAT PAT and NAT over PAT. So this is basically a concept which came into existence when the IP addresses on IPv4 addressing started becoming short. Or basically, we have very few IP addresses left. Then what happened is, or what we started doing is, for one public IP address, we created multiple internal networks. So if I have to show you, like currently I'm connected on my Wi-Fi, which is running on 192.168.1.4. So if I am on 1.4, there are other people connected to it as well, which would be on say 1.2, 1.3, 1.5. They would be connected on those IP addresses. But if you like check each of ours IP address on like what my public IP address is, so this is basically what our public IP address would be. But in networking, we cannot allow one IP address to connect to multiple locations. This is not how network was designed to work for. That is when the network address translation came into effect. Basically, the NAT concept. In NAT, what we did was we created multiple smaller internal networks for one particular private IP address. So whatever requests were being generated from the internal network, they would be sent over one particular public IP address itself. So now you would ask what PAT is. So PAT is basically port address translation. Now, same like the IP addresses, even ports can be masked, or basically not masked, your port can be changed. So if I have to like fire up Wireshark, if in I would like this, you all do it. If you have Wireshark installed on your system, simply fire it up on the interface that is connected to the internet and try going through any one of the packets. Try to find the source packet, and basically the source port, the destination port. You will always find a very like random port number. Some port numbers you like might not have why it is being used. That is because the ports have been translated as well. And NAT over PAT is a combination of all of this. So your IP address is converted into a public IP address from the private IP address, and as one public IP address is being shared between many internal hosts, we need the port address translation as well. So say suppose you sent any request from port 80 of your system on the internet, it would be shown as it originated from, say suppose, port 8000. That is what NAT over PAT is, and that is how basically all our current internet works on. So let me show you as well. So where is my Wi-Fi? Okay, so say suppose this is my source address, which is basically like 13.127.162.45, and the destination address is my IP range, which is 192.168.1.4. And if you closely look on the user datagram protocol, so this is a basic UDP protocol that is being used. The source port is 8801, whereas the destination port is 50,385. Even though I was not intentionally using this port, this is something that happened from my router on the internet. So whenever your requests are being sent, it is not always like the same port it is going to be used. Need to have, or you would be using a completely random port altogether. That is the primary reason whenever you go for any security audits or any security testing, you have to like port forward on your systems, so that if you get a connection or a reverse shell back to your system, you would be able to connect on the same port that you didn't define it to use. Say so suppose you used the port 4444, while sending the request on the internet, it might not use the port 4444. It might use a complete random port. That is the reason, though we don't tell people like on the YouTube tutorials that you need to port forward, this is the reason you have to port forward. If you don't port forward, you would be getting a completely random port on the internet. So whenever that system which you hacked into tries to connect back to you, won't ever give you a session. Okay, so like, let's keep it up till here. We have like endless things to discuss. You can join in for courses. You can join in for the other sessions that we would be doing. And let's have a word as to how we can help you, how you want to be helped. We would definitely make sure to help you out in any possible manner. So if you have questions, and I would be like happy to answer them out.
Hi, good evening.
Good evening, sir. Boliye.
So how was session, guys? It's too long, right?
Yeah, even boring. I know. Like, see, I cannot even do anything about it. Networking might be boring, but once you get into it, it is quite interesting.
Yeah. Okay. Anyone having any feedbacks for us? You can talk.
Feedbacks, questions, anything. I would love to hear the feedbacks first. More than the questions, I would love to hear the feedbacks first.
So for feedbacks, you can just send just fill up this form. Okay, and I'll sending you an email for feedbacks. So just revert back or fill up the same form. It will be the same form. Okay, so we're introducing some new things as well. We're going to start up red teaming from upcoming few weeks. Full packs. You're having networking. You got malwares. You got exploit development, and you got red teaming now. So other one we had about web application. So we are looking for that one as well. We'll be updating you on that one shortly. Other thing that we had about forensics that we have to start, but we are going to start it very soon once we get the things done. Okay. So if you got any other options or anything for me or for anyone, just let me know right now. You got any questions? You have any other doubts? Anything? Feel free to answer us and go through. Uh, um, okay. Seems so no one have anything for us. Let's have a look on YouTube and see we got anything or not. Awesome sessions from Tanmay. Thank you, Tanmay. Now, how likely you want this guy to be taking other sessions? Like if you want sleep time, he can give you that one. We want another sessions when it will be. अरे sir, चाचू,
बोलिए सर.
अगला सेशन कब लोगे?
Friday,
इतना डिमांड लोग मेरे को नहीं करते हैं.
Friday, Saturday तक.
Okay. Okay, so next session we'll be updating on you by end of this day, maybe tomorrow. Okay. And guys, you can ask the same questions on my session as well. Like when you're going to take other sessions, no one asks these questions for me. Bad. Okay, guys, so that's all for today, and hope we can see you tomorrow. I guess tomorrow we have a session. I'm not sure. Let's have a look. People who don't know, just go to our website. There's a calendar where you can see our sessions listed up like this. So any upcoming sessions will be here. Just click on the session link and your options how to join in. Okay, just click on more details. It will open up the page where you can actually go and see the details and stuff like that. Okay, and you just copy paste the link directly and it will open up the session stuff. You can follow us on different social media now. So we are available on quite a few. So you can have us on Twitter, on Instagram, even in what that thing calls LinkedIn. So we'll be seeing you there. About any trainings on stuff, we are going to announce that one as very soon. So one of those courses are available now, and you can have it on Udemy. That is for Himanshu, and he'll be telling you and giving you the information what he does and what course is about. So tune in, and we'll see you soon, I guess. So for feedbacks, please fill up the forms. For rest of the things, ping any of us. If you want to talk to Chandresh or any of our speakers, drop email to hello@aristi.live. And I'll be forwarding your messages directly to your speakers so they can revert you back. Okay, guys. So see you on next time. Till then, bye. And thank you, Chandresh sir, for taking this session today.
Welcome, sir.
Okay, sir. So we're wrapping up here, and we'll see you on next time. Bye, everyone.
Bye bye.